everyone, and welcome to Pathfinder, a podcast by Payload, the leading digital media company in the space industry. We're calling in today from Austin, Texas, on the morning of our first ever event taking place at South by Southwest on the role of space in national security. It's shaping up to be a great day, but first, we're joined today by Nate Hamet, CEO and co-founder of Quindar, a startup developing mission management software to automate the operations of satellite constellations. It's a great conversation. I hope you enjoy. Nate, welcome to the show.
Thanks for having me, Mo.
I'm very excited to have you. Where are you calling in from today?
I'm on travel right now, so I'm in California. Yeah, but normally based in Denver.
Normally based in Denver. Well, I am sitting at the South Congress Hotel in Austin, Texas. It's South by Southwest, and we, in about an hour, are going to be starting our event in Austin called The Ultimate High Ground: The Role of Space in National Security. So should be a good day. Should be a good day.
Awesome. Yeah, we have some folks attending over there as well. So excited to be connected in person too. Good.
Well, for now, you're in the hot seat, and you are the man of the hour. So, Nate, thank you again, and let's dive right in. So, maybe tell us a little bit about Quindar and what it is that you're building.
Yeah. So, satellites are just flying servers in space, and traditionally, if you look at photos of NASA or like the Apollo 13, movie, you'll see a lot of humans sitting in front of big monitors. And this is dozens of humans, and this is a 24/7 operation. And what they're doing is they're making sure that the spacecraft, the satellites are healthy and up and running. And so because satellites are really just flying servers in space, what Quindar provides is similar to what AWS provides their customers. And it's that servers need to always be up and running. And space is a very difficult, challenging, radiative environment where things can easily go wrong. And so what Quindar does is we provide a software suite to manage the uptime of satellites so that our customers can always connect. And, back to the AWS analogy, when you're connecting to servers at AWS, you don't know what manufacturer created that server. You don't know necessarily sometimes what operating system is running on top of it, what ISP you're going through, what data center you're in, where the region is. All you care about is that you can connect and produce your workload with the confidence of a very high SLA. And so that's what Quindar does for satellites, is we connect folks to their satellites and make sure those satellites are always up and running. So that they have the confidence that the next time they talk to their satellite, it'll be healthy and they can perform their payload, which might be taking high resolution Earth imagery, or that could be in-space service and manufacturing, whatever it is that this spacecraft is trying to do.
Yeah. So I want to take a step back and ask the question, what is satellite command and control? And on your website, you have actually a great series of blogs that talks about your company and sort of some of the some primers around, what service you're offering and what problem you're trying to solve. And I actually highly encourage folks that are listening to go and check it out because you do a really good job. My favorite one is the one that's just literally called "What is Satellite Command and Control?" And you go into it and you use real world examples for folks that might not have a strong understanding of what it is to make that leap. So maybe. I know we can talk about that for a while, but maybe if you were to give us a very quick sort of primer, like what is it exactly?
Yeah, so at the highest level, being able to command a satellite and control it is really, once you're able to connect to it, you have to tell it what to do. So traditionally, satellites do not have high onboard compute. They're not as intelligent as ground computers are, and so you really have to say, hey, if I see this temperature, I want to go and send this command to turn this heater on. Okay, then I want to check to see, is the temperature of that area of the spacecraft, is it actually increasing? Then I'm going to go ahead and do my next activity. And, taking it more towards the analogies too is, you can look at ground stations and antennas like your router at home. And so over the air, they're able to, send data from the internet to your desktop computer. And then, at the level below that is, the modem, which is really the language that we're speaking right now, English. Satellites all speak their own language. And so there's protocols and different languages that satellite speaks, and then at a level on top of that, on the physical layer, it's called, it's different types of modulation schemes, which we can get into details later, but I don't want to bore this audience. But really, there's different languages satellites speak, and so you have to make sure that the ground is all in tune to speak the appropriate language to each of these satellites, so that you can tell it appropriately to turn this heater on to make sure that the temperature of this area of the spacecraft is increasing slightly. And so command and control at its core is really just making sure that you can send commands in the right language to the right satellite, see the responses, and then tell it what to do next.
So you spent some time, and I want to talk a little bit about your own background. You were at OneWeb. You spent some time at Orbital Effects and Lockheed before that. Talk a little bit about how your background influenced, if it did influence directly, the creation and inspired the creation of Quindar.
Yeah, for sure. So the founders, we actually have 6 co-founders of Quindar, which is a lot, but we've been through a lot together. And at OneWeb, we were in charge of, with a great team, building out the operations center there. And so, in this terms of the software, there's a few core components of mission operation software. There's the flight dynamics software, which is really, where was my spacecraft? Where's it going? How is it going to get there? There's the mission planning, which is, once I know where it's going, when can I talk to it? And then also the other side of mission planning is, what am I going to do when I talk to it? Command and control is, again, what's the right language to talk to the satellite to tell it appropriately what to do? And then on the incident management, it's, when things go wrong, which they definitely can, what am I going to do to recover? And this is both the spacecraft and on the ground system if there's any interruptions. And each of our co-founders was a lead developer in those domains. And then, of course, mission management, which really just like glues everything together to make it as simple as possible to control a constellation or to control even just a single satellite. And so the co-founders of Quindar came from OneWeb and a great team. And what we saw, in 2016 when we started off out there, was mega constellation was new. Like, that term had never been coined before. OneWeb coined the term mega constellation. This is pre-Starlink as well. And so when we're trying to command and control 600 plus satellites, we're using technology, the best technology that we possibly can, that was slated to control, a dozen satellites or maybe a couple dozen satellites. And at that time, Planet had probably the most satellites in control. So that was about a little over 100. And what we built at OneWeb was amazing. It was successful. We have a lot of great stories that came out of it. But what we saw was mega constellation wasn't becoming a rare term anymore, that there were companies coming out wanting to build hundreds of satellites. But what we saw that is companies are going through these make-buy decisions of what commercial off-the-shelf COTS products exist in flight dynamics, mission planning, command and control, and incident management. How do I glue this all together? And a lot of these technologies weren't meant for the cloud. They're not cloud native. And so you're taking what's not cloud native, trying to adapt it to the cloud. And then they didn't have modern security. We were building security around this. And so it was just a huge lift to upgrade. That this can take years to get the right architecture in place to be able to support a satellite. And so at Orbital Effects, we did something very similar at OneWeb. And we realized that each company is doing the same thing. Like, they're either building it in-house or they're vertically, or they're gluing it together from commercial off-the-shelf products. And sometimes they still refer to that as, we build it in-house. And so that's when we were like, no one starts their company, except for Quindar, to do mission operations software. Like, they started it to create the most high resolution Earth imagery possible, to beam a service direct to your cell phone from a satellite, to beam internet, direct to user terminals around the world. So you can get, you can bridge the digital divide. But no one in that grand plan has said like, oh, I love mission operations. This is why I'm building the company. It's all a means to an end. And so that's when we were like, well, we need to build more of a utility, because that's what this is. The first principles really haven't changed since the late 60s and early 70s when we started flying spacecrafts. And to be able to provide this utility to others so that they can build upon their constellation without having to manage the infrastructure team, the software that all comes with mission operations.
You mentioned security. Let's talk a little bit about that. Why is that important to ask the obvious question?
Yeah, I think one of like the biggest examples came out, during the Russia-Ukraine crisis and when the Viasat modems were hacked. And, it's real world moments like that that you realize that, warfare isn't even physical at times, it's also cyber related. And so when you're able to connect to satellites that are taking care of, direct to cell phone or, military, whatever it is that you're doing, this needs to be a protected infrastructure, and then two is the ground and the software that you use connecting to that server in space. All of it needs to be protected, and so we use a lot of standards. We're SOC 2 Type 2 compliant, NIST 800 171 compliant. And the biggest thing that I've learned through security on the software side is it has to be built into the culture. It's as much as a human challenge than it is an actual application challenge. And so that's why for Quindar, day one, the first sprint, we implemented DevSecOps processes and also going through these security and compliance roadmaps because it takes years. And so companies that are building in-house, it's going to take years for them to be compliant so that they can service the US government, for example. And that just takes time and resources away from your true value prop of the company.
Let's talk a little bit more about the software itself, mission management software. How does it simplify the operations of satellite constellations? Like if you're talking to a potential customer, how are you presenting this, like what the value add and simplification that you're offering?
So the first thing is it definitely depends on the customer that we're talking to. And so I'll kind of break it up into segments here. So and the first is the startup. Like you don't have a satellite, you've never run operations, you're trying to unlock some financial investor doors so that you can build upon your constellation and your company. And so for that one, it's reducing burn and making sure that we're providing you with the quickest route to space so that you can enable your technology and open those doors. And so for us and for building out this software suite, it's really how can we do this at a more affordable cost than building it in-house, which is our biggest competitors, folks trying to do this themselves. On the second side is more of like, okay, you have one satellite. Now you're trying to go to 10, a couple dozen, or even a couple hundred satellites. And so what we provide, those folks specifically, and of course, the startups as well, is reduced human footprint. And so, there's no reason that mission operations cannot be lights out. And so lights out operations is where, the software is running the operations and the humans are maybe providing just input here and there and configuring the system, but there's no one on the night shift. And so that's where the term kind of lights out comes from. And so that's what we're providing our customers is there's different roles in mission operations that you might see humans in a room for. Flight dynamics is always analyzing, like, did my maneuver work correctly? And so you need to dodge space debris. You need to keep within your station bubble so that your service is nominal. All of this, you're constantly analyzing. And so humans are constantly analyzing, am I in the right orbit? Are there any conjunctions, which is really just two objects that may collide? And what am I going to do about it? Because fuel is also finite. So you don't want to just move to, decrease the probability. You also want to make sure that whatever probability it is, that you have the best chance of surviving everything. And so, for there, we provide a lot of the automation and analysis of, where are objects in the sky and how am I going to avoid them? On the mission planning side, that's also another role that you'll often see in mission operations. And so mission planning is usually, when am I talking to my satellites? Okay, I need to go and actually schedule antennas so that I can talk to them. And with the advent of ground station as a service, you're able to rent antenna time by the minute, but you're also competing with others who are trying to rent on the same antennas. This can get very congested when it comes to transporter launches, where there's ride shares and everyone, there's dozens of companies on that are trying to vie for the same antenna time. Or just in nominal day-to-day operations, you have an emergency. You need to talk to your satellite as soon as possible, but there's others that may have emergencies. And as the space economy grows, we're constrained on the ground by the number of resources that can speak to our satellites. And so In that domain, we automate scheduling of the antenna time. And when there is an outage, or if the spacecraft is in an anomaly state, we're able to automatically reserve the next visibility, which is the next time we can see the satellite from the ground station. We're able to automatically reserve that without a human going through this in their heads. And then the other value add there too is incident management. So what we provide is we are constantly analyzing the whole service chain. So this is the software that's running, the network, the ground stations, and the spacecraft. So spacecraft operations is not just is the satellite up and running. Just like AWS, we are monitoring the whole service chain to make sure that there's any interruption that we can automatically replan so that maybe your time shifts slightly for when you speak to your spacecraft, but that you can speak to it. And you're not going to find out the hard way, which is we were supposed to talk to it right now. We didn't hear any data. What's going on? And so that is a very typical process in operations. And then you gather kind of the five families together and you're like, okay, networking people, you go see if it's a networking problem. Okay, application people, you go make sure that the command and control software is working correctly. Let's call the ground station peoples to make sure that like the antenna was moving and everything like this. And so you're gathering all these people and coming back an hour or two later and then saying, did anyone find anything? And so that's just a waste of time. And so what we provide is insights into what's going on in that entire service chain so that we can automate that out and provide the highest SLA possible.
Let's based on what you're saying, one thing that kind of comes to mind right now is integration, right? So I want to talk a little bit about the challenges of integration. You're dealing with satellites from various different manufacturers. They're all speaking different languages or different dialects, so to speak. How do you address those issues?
Yep. So that's a challenge. That's one of like the biggest challenge, but that's one of the biggest advantages of Quindar is we understand that companies are going to go from a generation 1 to a generation 2 satellite. And so the language that satellite speaks, the manufacturer that built that satellite might change. And that's not something you worry about like in year 1. That's something you're going to worry about in year 8 when you're on to that finally. But then it all rolls down to mission operations being able to be backwards compatible and forwards compatible, which is very challenging. The second thing is we're seeing a lot of companies actually buy from multiple manufacturers, even in their initial fleet rollout. And so they're taking, different manufactured satellites that are all speaking different languages and then saying, okay, operations team, go ahead and command and control all of these satellites that are act in different ways. And so what we provide is we are abstracting away the language portion of it so that our customers do not necessarily have to care what language the satellite's speaking. Instead, they actually use our abstraction layer and we unify operations. And so in order to do a lot of that, we have to have relationships with these manufacturers because there's two parts to this. One is some manufacturers actually do provide operations. And so Quindar can actually supplement those operations and provide transparency to their customers on, how's the uptime of the system going. And then the second part too is, by being compatible with these manufacturers, really means we need to be compatible with the flight software that manufacturer uses. So that layer going deeper into, there's commercial off-the-shelf flight software that is available that other manufacturers kind of share. And then there's the satellite owners that are building, from the ground up. They are their own manufacturer as well as their own operator. They don't sell, their satellites to other people. It's just more of an internal thing. And so being able to abstract, those languages is really what we decided to do with our open architecture. And that open architecture just really means is that if you have different dialects that aren't commercially available, that are proprietary, that we are able to integrate into our system because of how we architected the software. So whether you're going from Gen 1 to Gen 2, whether you are taking multiple satellite manufacturers and putting them into your constellation, or you have your own proprietary satellite software that you're creating all vertically integrated, we are able to plug that into the Quindar system and abstract all that complexity away so that all you're doing is saying, when I talk to the satellite, send, this procedure, which might be petting a watchdog. But it doesn't matter what language Quindar is sending it to. All I'm saying is to say pet watchdog.
How do you touch or handle the data that's getting generated by these constellations or these satellites, especially with regards to privacy or regulatory compliance?
Yeah, so that kind of goes back to our open architecture. Is It's really customer dependent. When we started the company, we kind of had this one solution. That was mission management software. It's the whole suite, and this is kind of how it works. And then we quickly realized that everyone has different security requirements, data residency requirements, and so a couple layers to this is first is we built a lot of this as infrastructure as code. And so if we need to deploy into different geographical regions, whether it's EU or the US, we can do that to support data residency requirements. If the customer wants to just black box all of their payload data and say, handle the operations software, and then when it comes to the health and safety data, store that securely. But when it comes to payload data, like the images I'm taking, when you get that data, just ship it to me. Don't do anything to it, just ship it to me. So we can do that. Some customers actually want us to host their processing. So it's, let's, do the dissemination within Quindar and scale that out, and then send the end data, to these locations, or utilizing our API, people will come to you and fetch that data itself. And so when it comes to the data residency security requirements, because of the open architecture that we have, and we know that each region and company has different standards, is we can be pretty flexible to meet the customer needs.
You mentioned lights out earlier. So I'm curious, how far away are we? And I know, obviously you're part of the solution from like fully autonomous operations.
Yeah, I think that one is definitely, I'll say this. We had a customer launching on Transporter 10. Within a few days, they sent us information back saying that they had run, a few passes lights out, no humans in the loop. And a lot of that comes to the ability to actually test like you fly. And this is, I think, an overused buzzword. And people always say, hey, we actually test like we fly. But then you see that when they're building the satellites in the factory and actually sending commands in the factory, there's a completely different team and a completely different set of software that's actually running the operations, which is a problem. You're not actually testing like you're flying. What there actually means is we put it through some thermal vacuum or some vibe testing, because that's testing like you flying, or test like you fly, but they're not actually doing the software suite and the operations and melding them together. But depending on the type of satellite, there needs to be a lot more onboard compute processing on these satellites. And actually, Quindar needs to go more on the satellite. That's where we really want to be, is not necessarily in the ground, but on the spacecraft, because there's finally versions of flight hardware that can run certain databases and applications that we run day to day in servers. But traditionally, there hasn't been enough memory and CPU on board these satellites because of how power intensive it could be. So back to your initial question, is we have flown customers lights out. But for the rest of the industry to start to go towards that, there has to be a little bit more standards and automation on both the ground and on the spacecraft.
All right, I'm going to put my investor hat on for a second. How do you make money?
Great question. And so we have a few different types of customers. So typically, what we have seen is that software licenses are user based, or they are linear per satellite. And that doesn't work with economies of scale, especially as more customers are launching more satellites. And so what we do is we charge per satellite, and there's a pre-launch cost and a post-launch cost. And we found that our customers enjoy that because in our industry, unfortunately, there are delays, whether that's delay in the actual buildup of the satellite itself, or there's just a launch slip. And so we don't want to charge an upfront fee that encompasses a launch that never will occur that year and might slip into the following year. And so we want to make sure that we're not, affecting their bottom line and their burn. We want to make sure that we're enabling them to be able to get to space as quickly as possible. So that's how we charge, is a pre-launch and a post-launch cost, and it's the per number of satellites. And we have price breaks too, which is great, because you can't have, as we have scaled the system, these are nodes in the system. And that's what these really need to be treated as, not as individual satellites. These are nodes that are just added into the system.
And this is not one time, but recurring, I assume, or at some point there's a recurring component to this.
Yep, it's subscription based. So we do annual subscriptions for the service.
Got it. Um, I'm jumping around for a second, but I actually am curious. Outside of space, are there any markets that you're looking at to apply your software in? Is that something even on the roadmap?
We've definitely talked about it, and I think that's something that you have to talk about as a company. I see a lot of companies kind of create products that weren't intended to be products, and that is very hard on the engineering side to be able to support, and then also on just the product and pricing side, be able to actually support those products. And so there are other verticals, if it's really an embedded system, that's what we're focused on here as Quindar, because we're not treating these as satellites, we're treating these as nodes, and in the end they're flying servers in space, which is an embedded system.
Yeah. Okay. A couple come to mind, but we'll say that for the next show.
Yeah.
What kind of traction have you seen so far with customers, both commercial and government?
Yeah, so we just celebrated actually our two year birthday on March 7th. So in that time, we've learned a lot, and I'm very proud of our team and the company of where we've gone today with our traction. And so it ranges from a manufacturer who's providing operations to payload as a service. And so like a manufacturer might provide multiple payloads, but they only want their end customers to access one single payload, not to affect the bus, especially the health and safety. So we're able to actually support both of those use cases, payload as a service and the manufacturer operations. We also have folks who are flying multiple missions for customers. And so that's the beauty of Quindar too, is not only can we handle multiple types of satellites and unify the operations, but we can actually provide multiple missions in a unified interface. And so you can understand, SLA of one customer versus the next customer, or how is this problem affecting another customer? Our customer base ranges from startups to, folks who are scaling their constellation to, defense primes as well. So we're really happy with the types of customers we're getting, because it's very diverse, and the customer segmentation that it's involved in, because it's a testament to the product and how flexible we can be per type of mission.
Let me ask this question in this way, which is, what is your ideal customer look like today, given where the company is at? So I know you mentioned that obviously you know defense prime, startups, companies scaling their constellations, but if given where you are and where you feel most comfortable in delivering the full suite of your product set, like what does that ideal customer look like today?
Yeah, it's a good question. Because we are able to support a broad variety of customers, our ideal customer today is when you're going from one satellites to N satellites. And I say that because we can have a really, really good conversation of, hey, what were you using before? Why doesn't it work? What are your pain points? What does your operations staff look like right now? What does your IT staff look like right now? Because the value prop of Quindar to some of these companies is, we can significantly reduce the amount of humans you need to support the software layer and the operations layer. And then we can highly automate, and this is an on-call system. And so when things are wrong with the system, who is the team that is sleeping through the night that can answer the phone when there's a problem with the system that hasn't been seen before. And so if you're going from one satellites to N satellites, Quindar is able to handle your legacy satellite, but then also scale without scaling the humans involved in this process.
All right. Well, so I'm a customer. I just agreed to use the Quindar platform. What does the onboarding experience look like?
Yeah. So some of the questions that we ask our customers is, what satellite manufacturer are we using? Because if we're integrated with that satellite manufacturing, there's a lot of reused procedures that can be done. Do you have a software simulator, a flat sat, or even a Raspberry Pi? Anything that we can connect to that's an embedded system, so that we can test, commanding and controlling that satellite. What ground station providers are you on contract with? If you're not, then we do have ground station providers that we're integrated with. We're integrated with KSAT, Atlas, Leaf Space, and RBC signals. And so as long as they're within those domains, we can integrate those ground station providers. And then the last part really is, how do you want to run your operations? Do you want to have humans sitting in front of a console at all times? And you can totally do that. This can be like Tesla, where you're driving and the system's in autopilot, but you're just monitoring it. Or you can take off autopilot and actually drive the car. Hopefully in the future, you can be in the passenger seat and you don't need to be in the driver's seat on the Tesla side, but you can also do that on the Quindar side. So we try to see what your operations looks like, because we want to set you up with the correct configuration for your type of mission.
Are you competing with anyone directly in terms of offering a full suite, or are most of your competitors sort of offering one of the types of one of your kind of offerings?
Yeah, there's two answers to that. So the first one is, our biggest competitor is companies building this in-house themselves. The biggest misconception too, when we go to folks to ask, what they're doing with operations, is they say they're building it in-house, but they're really just gluing together commercial off-the-shelf products, and then they have the support team behind it. So that's one type. On the other side of it too is, one of the competitive advantages of Quindar and the team that started Quindar is we're experts in our domain. We've done this over a couple of companies, so we've also been operators, beyond software developers itself. And typically, companies are coming out with, "Hey, this is my flight dynamics suite. I just focus on flight dynamics," or "Hey, command and control. I just focus on command and control." And Quindar is focusing on the entire ecosystem, because what we've found is that you're just going to glue these all together, and you want to have one comprehensive platform that says, from where my satellite is with the GPS data, for example, all the way to sending a command. You want a complete system that talks to each other, so that when one part of those applications faults, whether it sees a fault or it has a fault in itself, that you have the integrations to be able to recover from that. So those are kind of like the two different types of competitors that we have. But the other thing that we noticed over the last 2 years is, integrations provide our customers options. And so, we do integrate with flight dynamics products that might compete with our flight dynamics products. We do integrate with, other command and control products as well. So we have Cosmos as our default command and control that we orchestrate. And so, we are trying to also provide our customers with integration options, so that whether they have a contract that's already been signed for a couple of years and they have no way around, not using this product, or maybe they have some really, really good internally made flight dynamics product that they made themselves because they're going to the moon, let's just say, is we're able to integrate with those pieces of the pie as well.
Where is Quindar based right now?
Yep. So we're a remote first company. Then we have an office in Denver.
And how many folks are on the team right now?
14.
How have you thought about kind of initial team construction in terms of like the types of folks that you've needed, and how does that look like, call it a year from now?
Yeah. So the first thing is high impact. Like we recruit and we retain world-class leaders, but also it doesn't have to be from aerospace. And so when we started the company, we wanted to make sure that we were getting different ideas from outside of our industry, outside of the aerospace industry. And so the founders were all technical, so it was nice that we could get to like an MVP without really having to hire. So that was one of the other superpowers of having 6 co-founders that are diverse. But we're all backend engineers, and so 3 of us had to learn how to create a user interface and a user experience. But that's also the culture. Is we might not expect you to know something, but we do expect you to want to learn how to do something. We want you to grow. And so as we grew, we hired a front-end engineer from the medical industry. Then we started to hire platform engineers, because Quindar is going to be operating the most satellites, maybe outside of Starlink, in the next couple of years. Because our customers are launching dozens to hundreds of satellites, and so that quickly adds up that Quindar is managing multiple types of mega constellations, if you will. And so we hired a platform engineer from Stripe, to make sure that they know scale. So Quindar needs to know scale on the platform side. And then we started to hire folks with machine learning experience, because one of the key products of Quindar, the key value props of Quindar too is, we're a gateway to space. We are able to understand, data upstream and downstream and to correlate them together. Or when there's a problem in the spacecraft, and you're not sure if it's a problem on the ground or vice versa, is how can you correlate these two problems together to come up with the right solution too, and then take, this in the past, this is how we solved this problem, and automate that into the system. So predictive, prescriptive, and cognitive, analytics is something that, we're building into the platform so that we can intelligently come to these decisions. And as we grow the team, that's definitely a testament of the business growing. And that's been a focus here at Quindar, is to make sure that the software scales more than even the team itself, because that's what we're building here. So it's kind of, drink your own wine. Is, we shouldn't be having to hire hundreds of people to be able to build this problem if we're building the right software.
So you recently had two pretty interesting pieces of news. So one, you guys are working, or you have an integration, I should say, with KSAT right now. What does that mean? What does that look like? And what's the importance of that?
Yeah, for sure. So on the KSAT side, as Quindar was building out its product, multi-mission operations was a key focus. Being able to command and control multiple types of satellites and multiple missions in a single unified interface without having to go into different tabs, into different user interfaces, without having to stand up different ground segments for all of these missions. It should just be one time that you're building the ground system, and then one unified interface on top of that. And so, what we noticed too is, customers just want their data. That in the end of the day, they just want their data. KSAT knows that extremely well, because, they're a ground station as a service provider. And so that's what they're providing is, the highest industry uptime to provide data to their customers, to make sure that their customers can get their data to do their workloads. And so, beyond, customers wanting their data and stuff like that is, what we also noticed is with KSAT, building out this, business unit for mission operations, is that people want this as a utility. People don't want to start up their own mission operations software suite if they don't have the choice. But that's the only choice they've had in the past, is that if you have a company that is flying a mission, then you have to stand up your mission operations software, and you have to support, provide the people enable to be able to provide service to your end customers. And so by KSAT, taking that next step really into the mission operations software side and utilizing, a multi-mission operations platform, we can have, the best solution for our customers to be able to manage multiple fleets, to be able to secure data, and to be able to provide the highest satellite uptime in the industry without putting that burden on our customers. And so this really helps validate that this should be more of a utility for the industry itself.
So about a month and a half ago, Payload covered a big piece of Quindar news, which is your seed extension round. You raised $6 million. What's the plan for the capital?
We were super excited, when we were able to raise that round, especially in a tough market. It's not easy in this market and stuff. And so that was further validation of the product that we're building here. And so what we're using that capital for is, one, to be able to hire key individuals that will be able to take Quindar into its growth stage for, machine learning, and to be able to build upon the applications that are able to correlate different anomalies across different parts of the value chain or the service chain. Two, it's to work more with the U.S. government. And so, we focused a lot on security and compliance since day one. And we've built a lot of commercial solutions that can also be utilized dual use for the U.S. government. They have the same problems. They're trying to build a unified ground system for multiple missions, but multiple branches are also trying to do the same thing. So by us proving out with our current technology, even with customers that are scaling, helps us to be able to service the U.S. government. But they also have different levels of security and compliance, things called authority to operate, high impact levels, impact level 6, which is secret and top secret. And so really it's being able to support, the US government as well, but there is a process to go through. And so that's what we're focusing on, is the machine learning side part of Quindar and the intelligence, but then also being able to bridge this with the US government.
What's next for the company? And or said differently, industry or investors, what should we kind of be watching out for?
Yeah, it's definitely going to be focused around the intelligent incident management side. And so being able to serve up the problem without humans diagnosing exactly, I didn't hear something, let me go dig into it. And then also being able to communicate with the application, just as me and you are talking here. So less clicks and less complexity, which is typically how mission operations is, because it's not simple, and abstracting all of that away, so that as we're integrated more with these manufacturers and ground station providers and flight software, is that we're really providing a more of like Datadog for space. So it's this high level situational awareness, and not necessarily this is how you track an orbit. This is how you reserve an antenna. All of that's handled in the back end.
How much of that Star Trek vision of sitting on that seat, Captain Jean-Luc Picard in the USS Enterprise, how much of that vision are you envisioning for Quindar in the future?
Yeah, I mean, like that's the thing, is I give our challenge to like folks who have never done spacecraft operations that are developing our front end or our back end, is like, this should be so simple that you can use it. And it's not like to say like they don't know, they wouldn't know how to do this. It's more of, this needs to be simple. This needs to be less complex. And so like we already have alpha projects that are showing some of these come to fruition that we're super excited to test with some beta users, and then of course to make generally public. So it's not too far off. I've seen some of the work that the Quindar team has done, and that's just a testament to the high impact players that we have.
There you go. When you are not building Quindar, how are you spending your free time?
Great question. Cooking. I love cooking. It's my time to just think. So I'll cook for like an hour or two. I'll eat it in 5 minutes. But it's a great time to bond with my wife, but also to take some time to myself and to think, and to master something that I have to do every day, which is to make food and eat food.
How do you have a favorite or specialty dish that you make?
Yeah, I can't say it's my dish per se, but I follow Kenji Lopez Alt. He's on Serious Eats. He's the author of the Food Lab, and being an engineer myself, he is an MIT graduate, so everything he does is based off of science. And so he created this kimchi fried chicken recipe that is ridiculously long, but it is mouthwatering. It is amazing.
Wow.
So if you're invited to my house and I make this, you're very special to me.
Is this a public? It's a public recipe, I assume, right?
Yeah, it's a public recipe. You might get scared with how long the recipe is, but just come over to my house and I'll make it.
Oh, that's amazing. What do you think about like the age of social media kind of food influencers? Because there's so many that I actually follow. Because like I feel like it's funny, when I and maybe this says more about me than it does about the industry, but when I like want to make something or make something unique or interesting that I haven't made, I actually peruse like social and like, on Instagram, like there's tons of like great food influencers that like, do these like 30-second, minute long, like clips of like how to make, a certain type of, recipe. And like, actually what I find nice about it is like, they make it seem at least like technically that it's relatively easy to do. But I don't know if there's anyone that you follow, anyone that you like out there, or what you think in general, but curious to get your thoughts.
Yeah, I often find that, those simple 30-minute meals are really simple 60-minute meals. And so, yeah, there's definitely a caveat to them. But one of the recipes that I follow, or the folks that I follow, is Nom Nom Paleo. And so, they're able to take just 4 ingredients and create these dishes. And sometimes when I'm in a rush, that definitely helps, because, starting and a company and being able to work, at the right hours of the day, it does take some simple meals sometimes.
Yeah, no, that's awesome. Well, it's actually funny when I remember when I used to be a avid Blue Apron subscriber, and the recipes would always say like, oh, like 20 minutes to make, or like 30 minutes to make, and it would never take that long. It would take so much longer. So
exactly.
Anyway, well, Nate, I really appreciate you being on the show. Thank you for that little detour on your life. It's always interesting to hear about, people are building such hard, complex products, what they actually like to do in their free time. So cooking is yours. So, hopefully one day in the future I get to try that kimchi fried chicken.
Yeah, no, absolutely. Hope that happens.
Well, Nate, thanks again for being on the show. Really appreciate it. And looking forward to seeing how Quindar grows.
Yeah, appreciate the time, Mo. Thanks for having me.
Until next time.